solid Q that is in the small hard glass test tube, we are supposed to heat this sample of Q gently first, so we do it with a air hole that's closed. Then we need to heat it strongly. After that, the question says to test for any gas using litmus and glowing spin. So before we start heating, we should get ready our litmus papers. We need to remember that when we test for gases using litmus papers, our litmus papers need to be dampened. So we control the strong weak flame using by opening and closing the air hole. So now that we want a strong flame, we will open the air hole completely. We will see that solid Q remains. There's a white solid in the tube, and there are some droplets, water droplets, condensing at the sides of the test tube. And then we will now test for the gas using our red and blue litmus. So we see that the blue litmus has turned red. The damp blue litmus has turned red, and then we shall wait a while to see if there's any change happening to the damp red litmus. The glowing spin test, we do see brown fumes appearing. Glowing spin also relaxes, and the white solid remains in the tube. So there are many observations we can make, and we will have to be sure to write all of them down in our scripts. Brown fumes seen, glowing spin relaxes, then blue litmus paper turns red, damp red litmus paper remains. When we heat, the tube will always be at the tip of the small blue triangle, like what I did. So when not using the Bunsen burner, we will close air hole, change it to a safety flame. Next, we move to part B, where we will pick up the large stoppered test tube labeled salt Q, and we are supposed to add about 10 cubic centimeters of the ionized water. We are making for ourselves solution Q. Given as a solution, we expect that all the solute would dissolve. That's the definition of a solution, where the solute completely dissolves in solvent. In this case, the solid Q would dissolve in water. Next, we will take 2 cubic centimeters of Q, put it in a test tube. So you see I put my dropper in the boiling tube so that I do not contaminate my dropper. I will repeatedly be using this dropper for my solution Q. 2 cubic centimeters of Q. We will add a few drops of sodium hydroxide, and then shake the mixture. So we see a white PPT being formed. Add some more 2 cubic centimeters of sodium hydroxide for PPT form. Next, we will add aluminum foil. We understand that the complete steps for part B is to add sodium hydroxide, add aluminum foil, and warm. And we recognize this to be a test for the nitrate ion, which is confirmed by the release of ammonia gas, which is confirmed by damp red litmus turning blue. So as I heat, I get ready my damp red litmus. So if my damp red litmus turns blue, it means ammonia gas is given off, it means nitrate ion is present. So as we heat, we have to be very careful when we're heating solutions. When it starts to bubble, vigorously move the tube away from the fire, carefully move it away from the flame, but continue to test for the gas. So both your left and right hands will have to move at the same time. Keep an eye on the solution, keep an eye on the litmus paper. Just pay full attention to what you're doing when you're heating. Be sure to that when you hold your litmus, the litmus is not touching any part of the test tube. So it's a positive test. Damp red litmus turns blue as the solution bubbles, as the PPT bubbles. Next, we go on to part C. We will take 1 cubic centimeters of solution Q, put in another test tube. We will add 1 cubic centimeters of aqueous ammonium. We add low PPT is formed, colorless solution remains. So that's the test for aqueous ammonia. Next, we will go on to part D. We will put 2 cubic centimeters of solution R in a test tube. This is the marble chips. We will have to add the marble chips in a test tube and then add hydrochloric acid. Marble chips is calcium hydroxide. So when we add hydrochloric acid, we know that the acid would react with the carbonate to produce carbon dioxide. Hence, the question calls this the carbon dioxide generator. It produces carbon dioxide, so it generates carbon dioxide. So instantly we see bubbles. And what we need to do is to pass this carbon dioxide gas through the solution R. So on the left side of the screen, you see the bubbling. The gas that is produced bubbled through solution R, and you get a white PPT, white precipitate form in solution R. Since we know that the gas given off is carbon dioxide, and we get a white PPT form in this solution R, that allows us to conclude the identity of solution R. Okay, we're supposed to bubble it through solution R, so white precipitate form, until no further change. So we will continue to bubble until something happens to the white PPT. So something is happening to the white PPT. You see that the solution is the PPT is going away. We are getting back a colorless solution as more and more carbon dioxide is being generated by the carbon dioxide generator. You could generate more carbon dioxide by adding more marble chips and more hydrochloric acid. But now I am satisfied that the white PPT was formed, and the further change was that the white PPT dissolved to form a colorless solution. So now I proceed on. This solution now that I'm holding is solution S, and I'm supposed to gently heat solution S until it starts to boil. That's the very last part of the experiment. So I heat, and then of course we pay attention to any changes that may happen in the tube. So whenever you're heating solution, if it starts to bubble vigorously, again just move it away from the flame for a while, for a short while, and then move it back to the flame. Always put the test tube at the tip of the small blue triangle, and in this case we see that white PPT begins to form again.